Right, so the first one, calculate the efficiency of the hairdryer. So you've got heat energy, that's the useful one. You start with 800 joules per second, or amount of energy from electrical. 40 of it gets used, so you get left over with 760 units of energy. So it says calculate the efficiency of the hairdryer with electrical energy, so underline that, to heat energy. So efficiency equals useful energy over total energy. So the useful energy is the 760, and the total energy that you got is the 800, because that's how much you start with. So 760 divided by 80 gives you 0.95, so that's the same as writing 95%, and that's your answer. The next bit, this is when you need to count. So to start with, you've got 100 joules of energy on the Sankey diagram. If you count all the squares, it tells you how much each square is worth. So I think there are 20 squares, so that means that each square is worth 5 joules. So you can answer C really quickly. That's 1 square thick, so that's 5 joules. You can answer B really quickly. That's 3 squares thick, so that's 15 joules. There's 2 ways of working out the next one. You can either count how many squares there are and multiply it by the 5, or you can say, well, we started with 100 joules, we've used up 5, we've used up 20, and we've used up 15. So that leaves 60 joules left. For the next bit, what happens to each of the 100 joules? So again, it's a case of counting squares. So you can either count how many squares make 100 joules, or easier is to count how many squares that make 25. So there's 1, 2, 3, 4, 5 squares again that make 25, so each square must be worth 5 joules. So we've got 1, 2, 3 squares of the unburnt fuel, so that must be 15. And then the next one, again, you can either count how many squares there are, multiply it by 5, or an easier way would be, say, well, you started with 100, you've used 15, you've used 5, so that adds up to 20. So 100 minus 20 gives you 80. Is that right? No, because you've got 25 here, you've got 15 there, so that makes 40, sorry, so that's 60. Then the next one, that's 3 squares wide again, but you know that you've used 75, you started with 100, so that one's got to be 25. So which one's more efficient? So the one that's more efficient is the stove, and that's because more energy heats the room. So both of them start with 100. The useful part of a fire is that it heats the room. The stove is 75, the open fire is 25. So it's got to be the stove. For part A on the next bit, which machine is the most efficient? Well, the whole point of a motor is kinetic energy, movement energy. So you're looking for the one with the thickest arrow, so in this case it's the electric motor, because it's the widest point just there. So the reason would be, you could say that this is the least amount of energy wasted, or you could say it's got the largest amount of kinetic energy, so movement energy. So then the next bit, what percentage of the input energy is useful? So you need to count again how many squares that is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. you said the kinetic energy is the useful bit. Count how many squares that is. 1, 2, 3, 4, 5, 6 squares. So it's useful energy over total energy. So the useful energy is 6, total energy 10. So that's 0.6 as the answer, or you could write it as 60%. And then finally, draw the labelled energy transformation Sankey diagram for a filament lamp. So two things with a filament lamp. So the electrical energy turns into light and heat, but it's mainly heat energy. So when you draw your Sankey diagram, you need to make sure that the light energy is a lot thinner than the energy that's lost as heat. So the heat one has to be far wider than the light one. So explain carefully what's wrong with the pupil statement. Well, what's wrong with it is that energy is wasted as heat. So switching lights off does not save energy. Since energy cannot be destroyed, it will always be there, so none is wasted. Well, it's because some energy is wasted as heat. And as well, energy can't be destroyed, but it certainly can be changed into something else and therefore wasted.